in the AWS Loft, we get a lot of questions about how to build a data lake. Often we recommend looking into AWS Athena, sometimes in AWS RedShift, but maybe we can cover RedShift, the details another time, but maybe let's focus on AWS Athena for now. Basically, let's go into some of the benefits that it has maybe in comparison to AWS Redshift, so we don't get carried away with Redshift itself. But yeah, let's kick this off. For example, what I like a lot about AWS Athena is that if you store your data into S3, it's very easy to query it. If everything's set up, obviously, and stuff like that, but also the cost perspective of it, doing everything like that. It's really crazy how they have actually built AWS Athena. If I'm correct, it's using Presto in the background, which then allows it to basically read like JSON, Parquet, Avro, CSV files like that. So if you have stored your raw events into S3, it's super easy to get them out. Maybe you can take over from here, Edward, and let's see.
Yeah, indeed. So if you just like you said, let's say that you have data somewhere, you want to query it. Let's say you run RDS, you pay every minute to have this RDS running, right? With Athena, you just upload the data to S3, you pay for S3 storage, and while you're not querying it, you don't pay. You only pay when you query your data. We then pay to process the data, $5 per terabyte currently in most regions. So it's often a very inexpensive solution compared to running a database 24/7. There are indeed use cases that fit better. There are some use cases where you would still have to run an RDS. For example, if you just have a website, an app, and you need to query information, you would run RDS.
Yeah, obviously.
But when you go closer to, I need some kind of data warehouse, then for exploration, Athena can be really good. So often the customers have that data in multiple data stores in RDS, maybe some on-prem platforms that need to extract data. So if you want to query all this data together, you need to bring it all together, right? Easiest way to bring it together is to write data pipelines, to use some tools. AWS has some tooling around that to bring this all into S3. And then once you have an S3, you can then choose where what you want to do with the data and how you want to query it. So easiest way to then do the exploration is Athena, I think. Like indeed, Presto compatible queries. Now it's a Trino that they use. But it's all the same. It's like SQL, very easy to use. A lot of statements are supported. You can do partitioning, you can do compression to lower the cost. So it's very easy.
That's an interesting point as well, because if you look at to go into one detail about the difference between Athena and Redshift, for example, is exactly that. Like the tiering in Redshift, if you go like above 160 gigabytes, it becomes super expensive really quickly.
Yes.
Like the entry step, it's like so you can get a taste for it, but then the next tier is like super expensive in comparison. Like if you have steady growth with and you use AWS Athena and you partition correctly, you can query super cheap. Like if you choose a correct partition and you have terabytes and terabytes of historical data, you can still query it all, but you just pay for the storage for those teras. And then basically you can, like if you have reporting that runs on a monthly basis, weekly basis, whatever, like you can partition on that time segment and only query that data while still remaining all that historical data, all those terabytes for whatever reasons you want to keep them. But if you want to accomplish that into Redshift, yeah, basically you need a new round of funding or something like that in order to pay for just that.
It is true that a lot of people start with Redshift and then it takes a very significant part of the AWS bill because it starts growing. You want to run queries under a certain time, and then you need a bigger cluster. a bigger cluster for 24/7 because you cannot you're not going to turn it off, right? With Athena, you only get you only pay for the capacity once you need it, right? And indeed, like you said, time series, a lot of data is time series based, or there's at least some kind of date in your data that you can query on or partition on, which means indeed that you can have all this data and you only pay for the processing on that specific part of data that you're then processing, which can be last month. So if you use some smart partitioning, you do compression, use a good file format like Parquet or something else, it can actually be quite efficient. Okay, the queries, it will not feel like querying an RDS table, a table in RDS and Postgres or MySQL. That's like super quick, right? It doesn't feel like that. It still takes a few seconds before you get your result. But for reporting purposes and for some use cases, that's perfect, and the price is pretty low. So let me share my screen for a second and just show you how this works, what an architecture diagram could look like.
Sounds good.
So I have here Lucy chart. I need to add the AWS shapes. So yeah, you would start with just an S3 bucket, right? Storage. And here, this is where your data goes in. So from your third part, from other databases, you ingest your data. Right? It can be an external database, could be RDS, some RDS data that goes into your S3. Then so actually the discussion I sometimes have with customers is, why don't we just put it directly in RedShift? You know, like, why don't we just take all this and don't put it even as S3? Let's just ingest it in RedShift, right? Because S3, the difficulty here is, of course, it's immutable. So how do you work with deltas? Then you have duplicate rows. Then you need to filter those duplicate rows out, which is all possible with Athena. But this just looks easier, right? The problem is going to be now, if you do it like this, now you still need to do your ETL because you just took a copy of your data and you just put it in Redshift, right?
Yeah, absolutely.
Okay, now you can query the data together. Now you can join the data. But you still want to do ETL, and then, okay, are you going to do your ETL on Redshift? Are you going to take this processing power from Redshift and then you have an even bigger cluster to then do the ETL on it, then then transform your data within Redshift? While still possible, it can be a quite expensive solution. So another alternative solution would be to just put everything as S3. It's not really an alternative solution. It's a solution.
Absolutely.
And then you have services like Glue, AWS Glue, right? Which you also need for Athena, because that's where also the schema is stored. And then you have Athena. But you can use Glue to then do your ETL. So in AWS Glue, you can run a Spark job to do your ETL, and then it can write its resulting data there. So then you only pay for the time that your Spark job is running, right? So you do your transformation, you need a lot of compute, you need a cluster, let's say 24 CPUs, you do your compute, 24 CPUs for 1 hour, the compute is done, you store everything in S3, the resulting data. So it's like a copy of your data. You have your raw data in S3, then you have a copy of your data that is transformed. And then you can either query it with Amazon Athena, or if you still want to use Redshift, because that's what you kind of want to use, you can still ingest it in Redshift or any other database. If you say, I actually have a front-end front-end app that I just need to have some data viewed very quickly, you could even say, I'm going to take some of this data that I processed, I'm going to put it in Amazon DynamoDB, and then I'm going to have an app that my customers are using, and this app is going to use this data, and now I can get access to this data very fast, much faster than Amazon Athena. Then there might be some reporting data that the app needs. Okay, then I'm going to use Amazon Athena to then get some reporting. So that's kind of all possible.
Yeah, absolutely. Like maybe you can also go a bit into detail, like how to get the data actually from S3 to Amazon DynamoDB. Obviously, now in if you look here in the diagram, it's aligned, but how do you actually achieve that?
There's multiple ways to get it in Amazon DB. So you could just run something in a container, and then you can
Yeah.
run it wherever. You could
So
run something in Glue
yeah,
that refreshes it. It
yeah,
depends kind of
exactly.
how many times do you want to refresh your data, right? Do you want to have it scheduled as a job? Then maybe every night you want to have it refreshed. It's going to be more something like a batch job. And
Okay,
also,
cool.
I didn't even enter this, but there's also still EMR. So you could even have EMR. I mean, I wouldn't recommend to use all these services, but you could say like, I'm not a fan of AWS Glue. It's too expensive for me. I already have an EMR cluster. Okay, then you're gonna use EMR to run a Spark job, or to run any job that runs on EMR. It's like a Hadoop cluster. For people that are not familiar with EMR, it's a Hadoop cluster. So you would just scale it on there, or you would run something on there that is then going to do the transformation, send it to RedShift, DynamoDB, or back to S3.
Yeah, absolutely, absolutely.
But I think Glue is a pretty good service to
Hmm.
use. It can also get quite expensive, especially for the compute. So another alternative that that I see people using is to use Amazon EKS. Amazon EKS is Kubernetes, which also allows you to schedule something on it. You can schedule your own Spark jobs using, for example, a Spark operator to define in YAML your jobs and then schedule it on EKS.
Yeah,
And
that
then now that we are
integration.
talking about EKS, we can also talk about Airflow. So Airflow uh, is a workflow manager, which also
Yeah,
is a service in ALS. So you can also use Airflow to define your jobs, put it in a S3 bucket, managed Airflow reaches from your S3 bucket, starts Airflow jobs to then also transfer some data or transform some data or ingest data or move it around. So when you're talking about transferring extract, so ETLs, there's a lot of options, right?
yeah,
So
absolutely.
you should kind of see what is my business case, what do I want to achieve, what are the services that I have available to do this, and then just compare them.
Yeah,
Compare what it costs to use Glue, and if that's too expensive, have a look at Amazon EKS Cloud or Airflow, because they all have different pricing mechanisms. But to actually do the queries, um, the to get some information out of it, I'm a big fan of Amazon Athena,
yeah,
just because
absolutely.
it's so inexpensive. As long as you just are storing data, you don't pay anything, and then when you want to run your queries, you then
Yeah,
pay for the data that is processed instead of paying a fixed fee all the time
exactly.
to just have it ready, which can be a bit wasteful sometimes. It all depends on the use case. But if you have a use case where Athena could work, I would definitely look into it.
Yeah, definitely, definitely. Um, um, like the cost perspective is something I found really interesting from it. Also, it's serverless. Basically, you have no management on it.
Exactly.
Obviously,
Yeah,
once
you
it's
don't have
configured,
to.
you don't have to upgrade it. You don't have to, like it's
It's
just
it's a good point because here with Redshift, for example, you still have to choose your instance type.
yeah, yeah, exactly.
So if your queries are going too slow, you have to pick another instance type.
Yeah,
Whereas here with Amazon Athena, you don't really have to pick an instance type. You
yeah.
run the query, query runs, you get your outputs. You
Which
can
also
optimize your
uses
query.
exactly, which also uses parallelism. So it's not that it's
Yeah.
super slow or something like that. Depending
No,
on how you partition your data, like from the experiences like we have with our clientele, like and don't think I ever came across that it was too slow or for the purposes at least. Like you have to choose the correct purpose for what it's meant for and not try to use an OLTP on Amazon Athena,
yeah,
obviously. But then there's still ways around it. Like with one client where we like where you pre-process the data using Athena and then populate it somewhere else. Like there's many options, obviously, but like
And
to
also,
query it,
I would recommend doing a POC. Like,
yeah.
if you don't know whether Athena is going to be a good fit for you, well, just ingest your data in S3, which you have to do anyways. Run some
Mhm.
ETL on it
Yeah.
to enrich your data if necessary, and then use Athena and use RedShift and compare them both and see which one gives you the best results.
Also, once the data is in S3, it also gives you the flexibility to like move around if you use something like you said, EMR or Airflow, whatever. Like if you pre-process the data and you keep the raw data and you move it somewhere else and try to do stuff with it, you still have that raw data. It's not
Yeah,
like
the raw
it's
data,
gone over.
exactly.
And then you choose whatever technology you want, but because like for now maybe it's a good fit, but after your company scales or other types of events, changing architecture or whatever, or other data, some technology can become more efficient, and you can still switch because you have all that raw data. That's also something important to mention, I think.
And S3 is also the most inexpensive way to store data on
Yeah,
AWS.
yeah, exactly.
So you just put the data where it's cheapest to store it,
Yeah,
and then you can do whatever you want with it later. But just let it stay in S3. Even if it's not accessed frequently, there's different tiers in S3 to get a better price.
yeah,
You can enable S3 intelligent tiering, for example, to automatically put your objects in a lower tier if they are infrequently accessed. So there is you also have to pay for get and put requests. So you still have to kind of have a good look at the pricing of
yeah.
S3, but just storing data and depending on if you can get in a cheaper tier is actually very efficient
Yeah,
price
there's no
wise.
cheaper
Yeah.
way on doing it in AWS actually. So it is that's like you said, like it's the most economic way of storing data. And
Yeah.
plus like storing hot data, and it's even becoming more efficient when it's cold data and you can tier it away to lower tiers while maintaining a high durability, because it's also important to mention, I think, like S3 is like it's a long time it's always a question in the AWS certification exams on how many nines it has, but I think it says like 11 nines in
Yes.
durability, so it's like super safe
And
as well.
and also a lot of people think S3 to get data out is slow. But for example, if you look
No.
at Glue, right, and you start your ETL, Glue will start, let's say, 12 nodes, right? So you can still, in parallel, those nodes can fetch different objects from S3.
Yeah.
So if pulling 1 GB takes 2 seconds, let's say, I don't know how long it pulls. It probably will be quicker, depending on bandwidth and all this, let's say 2 seconds.
Yeah.
But if you have 100 nodes, it will still only be 2 seconds to get 100 gigabytes out of it, right?
Yeah.
So because you have all these nodes, if you have all these nodes, you just do it in parallel. So it is still very, very fast to get the data out, as long as you can use parallelism.
Yeah, it's fast relatively to the amount of data that you process. Obviously, like an RDS is going to be faster, but it's not what it's built for. Like,
No,
it,
RDS
yeah,
creates you an index,
exactly.
and
Yeah,
because you have the index, it knows where the data is. So that's why you get the data out very quickly.
exactly.
But then when you write a new record, the index needs to be rebuilt. So that's why often people are like, okay, I do a lot of writes, and now my database is slow. Because every time you do the write, your database gets rebuilt. And that's when indeed if you need to do a lot of writes, so like here we need to do a lot of writes here.
Hmm.
You're actually putting those writes in bulk on S3 in big files, and once you have those big files with a lot of data, it's easy to process it. So to get 100 gig out of RDS is much more difficult to get. Let's say you have 100
Oh
gigabyte of
yeah,
data, right?
definitely,
It's much
definitely.
more difficult to get it out of RDS
Yeah,
than if you have 100 files of 1 GB in S3.
yeah, definitely,
Right?
absolutely.
So there's different use cases for every database
Yeah, but it's like
or
you
storage platform.
exactly. It's like you said. You just have to do POC and see what is the best use case for what scenario. No, right? Are there
But
any other things that we should mention as well?
I'm sure there are more services. like for example, you have this, what is it, this data migration service that you often use.
Oh yeah,
What's
yeah.
it called again?
DBMS, I think. Database
Yeah,
migration
so so Amazon also has a database migration service to make it easy to move data around from external databases to any service. So
Yeah.
when doing these kind of things, database migrations, you definitely have to have a look at this service, because that service can actually help you to move data around from relational databases.
Yeah, exactly. So you
Yeah.
can put that in
Was it
between.
data migration service? It must be here somewhere. Data migration service. That doesn't look this one.
Yeah.
Yeah, the AWS data migration service.
Yeah, that's the one.
Yeah. So you would use the AWS data migration service to move data around. So that's for external databases
Yeah, definitely
inside
do.
an RDS and so on. And yeah, there's also possibilities. For example, Amazon RDS can create a snapshot in S3. Amazon RedShift can import from S3. So all these services, that's the nice thing about the AWS ecosystem. They all support the other products as well. So you have a lot of built-in capabilities within the AWS products to link them with other AWS products. And S3 is one of the oldest services. This was one of the first ones that came out. So there's a lot of integration within all these other services.
Well, and also it works out of the box, kind of like you don't have to build too much to get you like you can hit the ground running basically. It can be optimized after a while if you see some that deep EMS might be more expensive than running a scheduled container every hour or something like that. But that's something you have to look into once you're there, if that makes sense.
Yeah, compute. Like once you want to run something, it's like this is like you're trying to solve a data problem, but then indeed you have to run then something like schedule something that's on
Yeah,
more of a compute problem, and then you have all these other services that you can have a look at to run compute. So
totally
it's kind
makes
of two
sense.
different problems to look at.
Oh,
So I
absolutely.
think this gets quite complicated. As in the reason why it's so difficult to get this right is because indeed you have the data problem, and then you have to get the data team in, and then you have to get the compute team in, or like could be like one person or two persons in a smaller company. But there's a lot of different
Mhm.
teams that need to get together to get this right.
Also, yeah, also the knowledge within the team is also super important. Like if you have to learn Spark, Kubernetes, how to deploy it, like it obviously influences the technology choices that you will make.
Yeah, and that's the last thing I want to say maybe is that writing in Apache Spark is still very different than just writing a single Python script, because you have this parallelism. This
Yeah.
is a distributed system. So data engineers definitely have to learn how to use distributed systems, how to write an ETL job that will actually benefit from having 10 or 20 or 100 nodes
Hmm.
to process that data. It's not a single Python script that launches. It's
Yeah.
actually a driver that launches and then that spins off, let's say 10 nodes, and then your Python code gets executed within those 10 nodes. So you have to make sure you only see part of the data.
Yeah.
So yeah, you have to make sure that you don't do too much in the driver, otherwise you don't benefit from the 10 nodes. And that's actually also a problem that we often see with Glue, that Python codes, it can be as simple as like you're executing an AWS CLI command, which gets executed on a driver. So all the nodes are not doing anything, and you're still paying for the nodes.
Yeah, they're still
Whereas you
hanging there.
should
Yeah.
exactly is where you should probably maybe do your ALC like commands before even starting
Yeah.
your cluster, then do the transformation because you have your cluster available. Then maybe do some post processing if you need to do something single node, but then the cluster cannot be running. So there's a lot of things you have to get right to also don't overpay on it. You don't want
Yeah.
any, in general, you don't want any resource in AWS to just be idle, because then you're just paying for idle resources, and that's expensive. You want to run something, run something on it, and break it down.
Yeah, absolutely, absolutely. And it's like you said, like those optimizations, in the end of the day, like it can save you a lot of money, because
Yes.
especially if it's like a lot of data and you're processing, like you said, in the driver, and you have like 10 nodes lying around doing nothing, and then like once they get invoked to actually do the work and are done in 5 minutes, but the other tasks, like there's a lot of optimization that can be done, obviously. Uh, um, But it's also that comes also from experience, and that's also like a bit where we can help. Like that's so
Yeah,
in that sense,
that's
that's
basically
a
our job where we help everyone setting this up and what are the
yeah.
pitfalls.
Yeah, absolutely, absolutely. Because we have seen in so many scenarios where it's been used correctly, but also where it's been misused, kind of, or in a less optimized way. Let me put it that way. That's
Yeah, it will
better.
it will work. It will work, but you will overpay.
Yeah, absolutely. And the thing with these things, it doesn't, you don't overpay like a couple hundreds per month or something like that. It's
No, no,
most
no,
of the
no, no,
times
no.
it goes about a lot of money that you can save on a yearly basis if you just optimize, like, then use the correct technologies for the correct use case. But that's not something I have to tell you, but like I wanted to give that to our audience as well.
Yep.
No, I think we can wrap up here.
Yes.
If you have any questions about this or whatever, always feel free to reach out to us. Always happy to help or discuss if something was not clear or give some more explanations, and then we can probably cover it in the next podcast or something like that. So thanks for being with us. Edward, thanks for your explanation,
Yep.
and we'll see each other soon.
Yep. See you next time.
Bye bye.
Bye.